As an engineer, I'm supposed to must use certain terms to describe the behavior of all eyes starting at birth. Some of those words are stochastic and ergodic. But I will really point to measurement made in office versus the measurement I made, say, I'm 2050. I have no trust in an optometrist because he doesn't make accurate measurements. That's me measuring 2050 on my home Snellen. And I know I must get to better than 2030 to be honest and sincere and keep my vision clear for life. So here is the question of accurate measurements, stochastic measurements. So you could say that's what I'm doing.
Video. This is going to be a quick lesson on the difference between deterministic and stochastic models, the advantages and disadvantages of both, and examples of when you might want to use each type of model. So these terms might sound complicated, but they're actually really simple. A deterministic model is just a model that doesn't involve randomness, and the stochastic model is just a model that does involve randomness. That's really all there is to it. The word stochastic might sound like a fancy term, but it really just means that something involves randomness. Another way to put it is that with deterministic models, if you simulate the model a couple times with the same initial conditions and parameters, you always get the same result. The simulation results are determined exactly by the initial conditions and parameters, but this is not true for stochastic models. Since a stochastic model involves randomness, if you run it a couple times, even with the same initial conditions and parameters, you might get different results each time. So to give you guys a quick example, let's say we're using the logistic growth model to simulate a population of cells that grows until it hits a carrying capacity of 100,000, and then the population levels out after that. This plot on the left is what a deterministic simulation of the cell population might look like. It's nice and smooth, and if we run the simulation again without changing anything, it'll look exactly the same the second time. On the other hand, this plot on the right is what a stochastic simulation of the same cell population might look like. This model involves randomness in the processes of cell division and cell death. So it looks similar to the deterministic model, except less smooth with more bumps and fluctuations. And if we run the model again, even with the same initial conditions and parameters, we get slightly different results due to the randomness in the model. So the question is, when should we use deterministic models and when should we use stochastic models? Both have some advantages and disadvantages. Deterministic models are usually simpler and easier to analyze mathematically and simulate. But even though stochastic models are usually more complex and difficult to work with, they're sometimes necessary to use. For example, there might be times when the randomness in a system is the thing you're trying to study, so you need to use a stochastic model to be able to capture that randomness. So, for example, when I was in grad school, one of the topics that my lab was researching was the consequences of randomness in gene expression. In particular, we were interested in the random bursts of mRNA production that happen when a transcription factor binds to the DNA. So rather than having a model where there was just a set number of mRNA transcripts for each gene, we wanted our model to include this random production in bursts of mRNA, as well as random degradation of the mRNA transcripts. And this was something that required a stochastic model because the thing we were interested in was the randomness of this process and its effects on the biology of the cell. So a deterministic model would not have been sufficient here. Okay, so that's all I have for you guys for today. If anyone has any questions,
There's a lot of reasons why an office measurement is not accurate. Repeated measurements and averaging the measurement, for instance, reading 2050 or 2060, tells you
just let me know in the comments and I'll try to answer them.
exactly where you stand objectively. You could use a minus lens to do your own checking, which is what I do. But ultimately, I must always exceed the required DMV requirements to be honest and to be sincere and ultimately to trust where I actually do stand on my visual acuity. So that's why I recommend at least verifying you can read 2060. And in my case, I use a plus to get to 2040 and eventually to substantially better than 2040, which would be the real purpose of wearing a plus. What you're doing is getting rid of the close work. The effect of close work doesn't get rid of the close work, but certainly gets rid of the effect. And then very slowly, you do better than 2040. So trying to work this with an optometrist is totally impossible. And if you have an optometrist who believes he's perfect and making perfect measurements, that's where when you have 2050, you walk out with a -3 diopter and are told how great it is since your vision is extremely sharp. And what has really happened is you've been prescribed a minus lens to give you 2010 vision. And yeah, admittedly, you're reading 2050 on your Snellen. But that can change, but only if you're willing to change yourself and commit yourself to the whole concept of the eye's behavior and prevention. Thank you. Add your own commentary.